Hi, welcome back. On today's lecture series, we are going to discuss about the synchronous motor construction and its operations. So, first of all, we should know what is synchronous motor. So, this kind of synchronous motor is widely used in the industrial applications. It is the most and widely used one of the motor. So the synchronous motor is also known as a constant speed motor because in synchronous motor it runs at constant speed, that is known as synchronous speed at 1500 rpm. So it generates an rotating magnetic field while running at the constant speed of the synchronous speed. So normally a motor which is used to convert the given electrical energy into the mechanical energy. Okay. So these are the construction of an synchronous motor. So here there are two machines, one is synchronous motor and another one is synchronous generator, or it may be called as an alternator. Just you can see the construction, everything is same. The synchronous motor which is similar to the synchronous generator, or it may be called as an alternator. Okay. So here also it is similar to the synchronous generator or alternator. It has the major two type component. One is called two types. One is called stator and another one is rotor. The rotor is nothing but an field. The rotating part is nothing but an field. So for field here we are giving the DC supply. So for field winding the excitation is given as DC supply, and this is similar to the alternator. And in the motor the armature, that is the stationary part. So in alternator we are taking the power supply, we are taking the supply from the stator and that will be given into the load. But in motor the load is instead of load we are replaced as source. So here we are supplying the three-phase power to the stator. That is the difference between the alternator and generator. Okay. So here in synchronous motor, so here it has stator and rotor. For rotor we are providing the DC power supply, and stator we are giving the three-phase power supply. That is the difference. Okay. So here already we seen the stator. So here in stator it may be a star connector or delta connected three-phase winding. So for the excitation here we are giving the three-phase AC supply to the stator. So the stator winding is also called as an armature winding, and rotor and rotating part. So the rotating part it may be either salient pole or it may be a non-salient pole construction. So the rotor it may be also the rotating winding, rotor winding is also called as an field winding. For the excitation of field winding here we are providing the DC supply through slip rings. And so what is the principle here? Here the main principle is called magnetic locking. When the two unlike poles it keeps near, which is very near, so the two poles it will be attract. This attraction is called magnetic coupling. The two fluxes will be attracted. The north pole and two unlike poles will be attracted when it is very close to each other. So due to this principle the synchronous motor is operating. So here it is based on the speed of 1500 rpm. It is based on the synchronous speed NS is equal to 120 F by P in revolution per minute. Okay. So why this motor is not self-starting? So here now we can see here in this diagram. There are two coil, that is there are two poles in this stator. One is N1 and S1, which is on the stator poles, and in the rotor N2 and S2 are the rotating part. Okay. So here the two unlike poles N1 and S2, because these two poles will be two unlike poles, opposite poles N1 and S2, or N1 and S2, or S1 and S2, which is brought near each other, so that only the magnetic coupling will be possible. Okay. So here at this condition, when the two stator poles are at position where it is vertical, so when the S2 is attracted by the N1, which is attracted by the N1, and N2 is attracted by the S1. So while it's two unlike poles which is very near, the magnetic locking will appear. Okay. So at this time when S2 is planned to move near N1, momentarily the N1 is changed as S1 because the speed of the rotating magnetic field is 1500 rpm. The stator field is rotating under 1500 rpm. Okay, so here the N1 is changed as S1. Okay, so okay, now the N2 can move into the S1 so that we can get the magnetic locking. So if N2 is planned to rotate in the anticlockwise, immediately the S1 is changed as N1. So at this condition, so the rotor is still in a stationary position. The rotor will not rotate. Okay, so the rotor will not rotate. Once the rotor gets rotated, which is near to the synchronous speed, which is near to the synchronous speed. So due to the magnetic locking, the two poles will be attracted each other, and we can get the magnetic locking. So the speed of the rotating magnetic field and rotor is both 1500 rpm. So once it's synchronized, it will rotate automatically. Okay, so okay, whether the synchronous motor is self-starting or not. So put your answer in the comment section, and these are the few references. Thank you.